So hello everyone, this is lecture 27 for the mathematical physics. In the last lecture we did up to here and we were trying to solve the homogeneous equations with the constant coefficients and not just trying, we already did solve the questions. Now let's see some more examples. Here the given equation is in this form: y double dash plus 2y dash plus y equal to 0. So constants are coefficients are constants, so we can use the same formulas. So we just write the characteristic equation first. This will be this: lambda square plus 2 lambda plus 1 a lambda is equal to 0. We'll find the value of lambda from here. It will be minus 1, means both of will be minus 1 minus 1. So we'll use this formula: c1 plus c2x e to the power minus lambda x e to the power lambda x, so lambda is minus 1. Now we have the initial conditions: y0 equal to 0, y dash 0 equal to 1. So find the differentiation of this. It will be this. So y0 at 0 will give you c1 equal to 0. Then you can find the c2 using this second condition. You will get c2 as 1. Substitute the values and you will get the solution. It will be this. Let's take one more example. So y double dash minus 4y dash plus 4y equal to 0. So it will be lambda square minus 4 lambda plus 4 equal to 0. Lambda will be 2. Okay, so means both are same, so use the same formula as we used here. These are the initial conditions and we need to find y minus 1 upon 2. So we'll use this formula, substitute these initial conditions and find the c1 c2. c1 will came out to be 1, c2 will be minus 2. Substitute, then you will get the solution. To find the y at minus 1 by 2, this place minus 1 by 2 in the place of x, so you will get y minus 1 by 2 as 2 by exponential e. Okay, now there is this equation, so it's just same here, just in place of x we have t and in place of y we have x. So it will be y double dash plus 2y dash plus y equal to 0. So it will be again lambda square plus 2 lambda plus 1 equal to 0. Lambda will be came out as minus 1. So we'll use this formula again, solve it and use the initial conditions and find the value of c1 c2. It will be 0 and 1. Then substitute 1 and 0 in this equation. You will get x is equal to t e minus t, and you can now find the any value will be asked. Okay, so this will be your solution. Well, there is one more thing asked in this question, that is the solution xt attains its maximum value when t. So we need to find the maximum value of xt. So you know from this your 11th class that when there is this function given and you need to find the maximum value, then you will differentiate it with respect to the independent variable, then equate the result with the 0, and the value of t or x will give you the maximum or minima points. So you need to find if it is maximum or minima. So from here you will get t equal to 1 or infinity. So now you need to check whether it is maximum or minima. So for that you will find the second order derivative of this. X double dash will be this. Now to check, you will put t equal to 1 here. So after putting 1 here you will get this, and this will be negative. So if second order derivative is less than 0, then we have the maximum value, and when it is greater than 0 it will be minimum value. So we are getting negative, so t equal to 1 is the local maxima. So we'll get the maxima, the xt attains its maximum value at t equal to 1. So this will be your answer, t equal to 1. If you check at the infinity you will get 0. Now there is this kind of question also can be asked. Okay, so here you need to just analyze these question, means the equation given. Okay, how? So this equation is given, now we need to turn it into the linear form which we know. Okay, so how you can do that? Just see this one, if you differentiate this 1 upon x dy dt, x dx by dt, then solving this equation will give you this. How? If you take this as first function, this is the second function, use the product rule. So differentiate x, you will get 1 and write it as it is. So you will get d square x by dt square. Okay, and x will be 1. So just pay attention here. See, here we are differentiating this whole function with respect to t. So when you differentiate x with respect to this, so you will get dx by dt not 1. Okay, so first function is this, put it as it is, find the differentiation of this. So you will get d square x by dt square multiply x and multiply 1 upon x, so you will get only this term. Plus now differentiating x, you will get dx by dt multiply dx by dt, so you will get dx by dt ka whole square multiply this 1 upon x. So after solving this, you are getting again this minus dx by dt. So after solving this, you are getting this. So you can write this whole term as this. So this is this will came to you after observing many equations. So it needs practice. Okay, so you need to analyze the equations like this. So now you can see that just multiply this whole equation by x, you will get this, and here you can put this x dx by dt you are having and x dx by dt you are having. So if you substitute here y in place of this, so you will get something this dy by dt minus y equal to 0. And now you know this equation, you are very much familiar with this equation. This is nothing but linear first order differential equation, and you know the solution of this kind of equation, that is y equal to c1 e to the power t. Okay, so we have the solution. Now in place of y we can write this x dx by dt equal to c1 et. Now use the separable method, dt will be this side and it will give you x square by 2, and here it will give you et plus some constant. Now there was this initial condition given, x at t equal to 0 0. So use this, at t equal to 0 x will be 0, so you will get c1 plus c2 equal to 0, and at x equal to 1, at t equal to 1 x1 equal to 1. So we'll put x1 will be 1 upon 2 and t equal to 1, so c1e plus c2 equal to 1 by 2. After solving this equation, you will get c1 and c2 as this, and c1 is nothing but minus c2, so we'll substitute here, means c2 equal to minus c1. So c1 minus c1, take c1 constant common, et minus 1 here you will get. In place of c1 you can write this 1 upon 2 e minus 1, so you will get this equation. Now at t equal to 2 you will get e square minus 1, so e plus 1 e minus 1, e minus 1 will cancel out and you will get e plus 1, so 2 will cancel out and x will be under root e plus 1. This will be your answer. Now this kind of question can also be asked, means this is a previous year question actually. A particle moving in a 2D satisfies the equation of motion this. So particle is moving in 2D. So there is this function which is depending on two variables, and both two variables means both coordinates depending on this third variable t. So x dot t is given equal to xt plus yt, and y dot t is given as xt minus yt, with some condition is given x dot at 0 equal to 0. So what is the ratio of x infinity divided by y infinity? So we need to find this. So for this we need to find the value of xt and yt separate, means we need to find the solution in terms of xt and yt. So how we can do that? First we need to use the any of the equation and make it to the only two variables, means one independent and one dependent, so either xt or yt. So let's see. So from here we can write x dot is x plus y and y dot is x minus y. So if you double differentiate it again, you will get x double dot equal to x dot plus y dot. Now from here you can write y dot equal to x minus y, so it will be this. Now you need to remove this y from here, so see how you can remove. So y equal to x dot minus x, just substitute here, so this will cancel out, you will get 2x. So now you are having the equation in the one form only with the x as the dependent variable and t as the independent variable. So this is the form we know. This is the linear differential equation in second order and homogeneous. So we know the solution. This will be lambda square minus 2 e lambda t equal to 0. So from here you can see that lambda is plus minus root 2. So you will use this solution x equal to c1 e lambda t plus c2 e lambda 2t. So we'll use this. Now this is our solution. So you can find the x dot from here, and x dot at 0 equal to 0, this is given. So we'll substitute at in place of t 0. So you will get root 2 c1 minus root 2 c2 equal to 0. So c1 minus c2 will be 0 and c1 equal to c2. we find this. Now in place of C2 we'll write C1, so you will get the solution for x. That will be C1 will be taken common, then e root 2t plus e minus root 2t. That will be our solution for xt. Now you can see that yt is x dot minus x. So you know x dot from here. This is x dot. In place of C2 write this C1, and this is x dot, and this is x. Right, in place of C2 C1 because both are equal, and x dot minus x will give you y. So this will be your y. Now you have y and you have x, and you need to find this x infinity divided by y infinity. So when you take the ratio, take this root 2 common, C1 common, they will cancel out. Take the e root 2t common, so you will get something like e minus 2 root t, means all the exponential function will be negative. So when you put t infinity, you will get the zeros somewhere, means they will cancel out, and then remaining will be 1 upon root 2 minus 1. So after you rationalize that, you will get root 2 plus 1 as your answer. So try to solve. These are just simple algebra, okay, mathematics. So main thing was this, how to use these equations and find the solution. Okay, so just go with the question, whatever question is saying, and you will get the answer. Now there is this one thing more, means you can get a differential equation in form of this. This is called the Euler-Euler's Cauchy form. So here x square y double dash plus a is some constant x y dash plus b y equal to 0. If you are having some equation in this form, then you can find the solution. Okay, how? So let's substitute in place of x ez. So from here you will get dx equal to, you don't need to remember this is just a proof how you can find the solution, but you need to know how we find the solution. So x equal to ez, so dx will give you ez dz. Okay, from here you can just reciprocal this, so 1 upon d dx, this will give you 1 upon ez dz. So, and ez is nothing but x, so we'll write in place of this x, and x will go this side, so x dy dx equal to dy dz, and we call this as operator d. Okay, so we are doing just we are replacing these terms x y dash x square y double dash by a single operator. So that's how we'll gonna find the solution. So now we removed this xy dot as capital D, this is operator D, with some third independent variable, that is z, dy dz. Okay, so let's now find for this also. So dy dz is capital D. Now this we have this equation, differentiate it again, so we'll get d square by dx square, second order derivative. We can write this as this dy dx and dy dx, and dy dx is nothing but dy ez dz. So this will be this dy dz 1 upon ez dy dz. So this will be this, means this 1 d upon dx will give you this 1 upon ez dy dz, and the second d upon dx will give you this 1 upon ez dy dz. Now we will differentiate this whole term with respect to z. So use the product rule, just write it first and differentiate second, you will get d square by dz, plus differentiate this, you will get a minus 1 upon ez, and write this as it is, so you will get this equation. Now just multiply this inside, you will get 1 upon e to z, d square by dz square minus d by dz. So we'll take this 1 upon ez common from both terms, so you will get this. Now you know that ez is x, so 1 upon ez square, that will give you 1 upon e to z, so it will be 1 x square. Okay, means 1 upon x square, ez is x, so you will get 1 upon x square here, and this is nothing but d square minus 1. See, this ez is x, so you will get x square here, so x square will go this side, so x square d square by dx square equal to this d by dz is d, capital D, so this will be d square, so d minus 1 will give you x square d square by dx square. So now we replace this also, this was x square d over d x square y square, this was this, so we replace this also. So now we have this in place of this xy dash d operator In place of x square y double dash we have d d minus 1 operator. So we'll just substitute it here and take the y common from all. Okay, because operators are only this capital D, not the y inside which we were differentiating. So we will take this out. So it will give us this d minus 1 plus ad plus b y z equal to 0. Now this y is the function of z, okay, not the x, because we changed the variable. Independent variable now is z, and the relation is here x equal to ez. We will substitute it later when we solve the equation. So now we are getting this. So d square minus d plus ad plus b will give you this d square plus a minus 1 d plus b y equal to 0. Now we know the solution of this equation because this is a homogeneous equation with constant coefficients a minus b and b. So you know it can be written as y double dash plus a minus 1 y dash plus by equal to 0, and we know the solution because this is a homogeneous equation with constant coefficients. So how you can find a solution? Just lambda square plus a minus 1 lambda plus b equal to 0. So that's how you can find the solution. Means you just analyze the equation and compare for the a, and you will substitute here the a minus 1 and substitute here the b, find the solution. In the last you will substitute in place of z, it will be log x equal to z. So in place of z you will write the log x, so z equal to log x. So let's see an example, it will be more clear. So x square y double dash minus 2.5x y dash minus 2y equal to 0. So see, this equation is something like this: x square y double dash plus ax y dash plus by. So b is minus 2, a is minus 2.5. So we'll substitute here d square plus a minus 1, this is minus 2.5 minus 1, and this is b, so it will be minus 2y equal to 0. This will be this, and this use a solution for the homogeneous equation. This will be lambda square minus 3.5 lambda minus 2. You will get lambda as minus 1 by 2 and 4, so both are real. So we'll use the formula this: yz will be c1 e to the power lambda z plus c2 e to the power lambda 2z. So in place of z now write the log x, because we know what is z is log x. So log x to the power minus 1 or 2, use the formula that is e log x equal to x. So that will give you this answer. So this will be your solution. Now let's take one more example for this: x square y double dash minus 3xy dash plus 4y equal to 0. So see, this is also a same kind of equation, Euler's Cauchy form. X square y double dash a xy plus by equal to 0. So a is minus 3 and b is 4. So you will get the equation as y double dash a minus 1 is minus 3 minus 1 minus 4, and b is 4. So this is the homogeneous form. So lambda square minus 4 lambda plus 4 equal to 0, lambda will be 2 2. So both are same, so we'll use the solution as this: yz equal to c1 plus c2 z e to the power 2z. So in place of z we will write the log x, simple, and you get the solution this. Okay, so that's it, and so today's lecture ends here. In the next lecture we will see about the Wronskian, this. Okay, so just do it up to here and see if you are facing any problems or doubts. Put it in the comment section. Thank you everyone.